So our last presenter speaker of the day is Johan Hultman. Johan Hultman joined, he still indicates it, Sartorius. At the time he joined it, it was Umatrix in 1999, and has since become the organization's top solution and software salesperson. He has a robust technical background in advanced data analytics in AI and machine learning, and this is combined with exceptional solution selling skills. I know, I agree. Johan now serves as the head of automation and data specialist in the digital solution group at Sartorius. And as a member of the leadership team, he has played a pivotal role in implementing SIM card technologies across various hardware and software applications. Great to have you here.
Thank you.
Especially with your busy schedule. And stage is yours.
Thank you. So I'm cheating here because I'm not always allowed to do these things anymore and do the type of presentations, but this was planned a couple of months behind. So what I will talk about today is some of the technology that we have built into our software to make your life easier. It's not a unique feature, but what we did was that we implemented something with a guided workflow so that it makes your life easier. So you can adopt the technology without understanding all the maths, without being able to be an expert in all the different disciplines that comes with this. So I'll talk a little bit about the background, about this calibration transfer, something about the technology, and then we have a couple of applications as well. So, and again, this is a challenge, last presentation of the day, but I'll keep you awake at least. So, when we are transferring multivariate calibration models between instruments, it can be challenging. We heard it earlier today that the instruments are supposed to be exactly the same, supposed to give the same results, and I'm challenging that. So I'm saying that I've never seen an instrument or two instruments from the same vendor giving exactly the same results. So how do we then accomplish this? And especially in today's situation where we work on a global basis. So it's not just in my laboratory that we have the instruments. We have different sites across the globe, and we would like to make this as easy as possible. We would like to have one type of model used across multiple instruments, giving me the same results. And if you then start with that the data coming out of the instruments is not always the same, then you can see that there is a challenge, but it's also manageable. So why do we from Sartorius, or Umatrix, as I would still like to say, I'm old enough and I have enough gray hair and pondus to say that I'm a Umatrician. But well, we see more and more of the process analytics in the biopharma industry. And this is, of course, where Sartorius is mostly interesting. But it works in all other industries. And our software is supposed to be agnostic, and we are supposed to use it in the chemical, the food industry, the pharma, and the biopharma. And when we look at the different instrumentations that we have, we look at different vendors, and of course, when we see companies have not one or two anymore, they have 10, they have hundreds of different instruments. The model maintenance, the effort of bringing this up to speed and making sure that you do this and document it in the correct way, this is one way of making that a little bit easier at least. So, what we try to do is to look at calibration transfer. It's a PLS model. We go back to the workhorse again. And what we have here is, if we now have a research and a manufacturing site, well, I see some spelling errors. It was late when I did this. There is a need to have harmony between the instruments. It can be between reactors or different processing lines or anything like that we would like to see. It can also be between different instruments in different setups and from different vendors and working like that. So it's also about knowledge sharing. So how can we make sure that we use this in the different scales that we have? Removing this burden from updating models, building new models for each system, and it makes it easier as well when it comes to convincing management on how to use the technology. Because again, if we can reduce that burden of work in order to set this up and maintaining it, then this is something that is really, really good. So, if we do this, we can speed up the deployment. We can increase not only the parts that can be effectively modeled, but we can also assure that the process is consistent between the different scales. So at Sartorius, we work a lot with these mini bioreactors, the small tic-tac boxes of 15 milliliters up to 2,000 liter scales. So is it possible for us to use similar models in the different scales? And my life has actually become a lot easier as being part of Sartorius, because before I only had access to the data that was given to me from customers and partners. Suddenly now, we are part of making these instruments as well. I have control over that. I can actually ask for the data and push them to make updates to the software so that I can get access to all the data and play around with. So this has been a fun experience as well, trying to do this with the different scales and making sure that we have models that works in small scale, moving up to large scale, or when you're trying to optimize, if you already are in a large scale, then can I then go down to a small scale, trying to do some optimization, and then actually use that instead of wasting additional material and resources that we have. And again, if we can use these predictive models for the critical process parameters, between instruments, when we look at the sampling window or the probes, for example, which is also interesting. We can do it between the actual instruments, but also with different instrument types. So looking at not only instruments within the same technology, but also within the different NIR, Raman, for example. How can we compare them and use that? So some of the work that has done is on a Amber 250, so this is a 250 milliliter scale that we have, and then the biostat STR, so we are up to 50 or 100 liters or something like that. And here on the left, we have a Tornado instrument, and we have a Kaiser instrument. And we can actually work with this and have the same model running on both of them, not only because of the scale, but also because of that they are actually the same instruments. That will make life easier. If we then look at the technology here, and I will not go so deep into the details. I can provide the documentation behind it and everything like that. But we use something called a piecewise direct standardization. It's not the only thing that works, but again, this is tested. This is proven that it works. So it's a good another workhorse that we are looking into. So we are fitting different PLS models into a moving window. You have to be sure that the samples from the parent and the child data set, they match. So you actually have the same setup, at least when you start building that first model. So we call it a child data set and the parent. So the parent is where you build the first model, and the child is where you would like to move this into the setup. And we added this guided workflow where you import the data sets, you tell it what is the parent, and then you tell it what is the child, and then I will show you in the next slide or a few slides what it will look like. So we take this child data set from the new instrument, we calculate what is the difference between them, we add that to the model, and then whenever we have a new sample, it will use that within that prediction setup so that we can move on and generate this in the best possible way. The output model will automatically then use this calibration part to adjust to make sure that we do this in a proper way. And that is saved in the configuration file, the data file that you actually have. So that is also part of this. Yeah. So, of course, when we come back to the practical things, it only works when you have a well-functioning model, of course. I mean, if you have a crappy model from the beginning and then you put in another instrument and say, well, let's try to make them look like each other, well, that will not work. So you need a proper model. But you all know that, so I don't have to dwell on that anymore. And this wizard will guide you through the different steps that you have. So inside the software, you have this calibration transfer setup. And then it will look like this, where you select the data set, you select what method that you would like to use, which data should be included, and then also you will get a summary. So that whenever you need a justification for this, you already have that. Which is also important. So let's look at some applications here. So here we have 3 different instruments that we look at, an NIR instrument, and this is what it looks like in a score plot. So what we would like to do then is, of course, to move this setup here up to here, and the other one is also. So we need to choose something as the parent. Yeah. How to do that and what to select here, I mean, it's not only if you like green color or blue color or something. There has to be also a justification why you choose this as a starting point. But you can move anything around in any direction, so that works. You can see that there is small differences here. And again, what we are trying to do then is, with this instrument-to-instrument transfer, we would like to use the model 1 that was built with instrument 1 as a parent instrument, and then choose the model 2 and to move that into the same area as we set up. And then, of course, we have the technical setup regarding how to do this, and also have a transparency of what was done, so that we can go back and justify this at a later stage. And then, of course, this model will then be uploaded into a system or a new real-time setup, and then when you have new data coming in, it will do the pre-processing, it will do the calibration transfer and everything, and what you will get out is a prediction based on this. As it's a PAT setup here, so we also have a Raman data set. Similar here, I have a couple of different instruments that we can do the same thing with, move that so it looks the same. I used the example before of a tornado and a Kaiser system. If you have multiple ones, we can make sure that you do this in the best possible way. Yeah, so that you can choose and buy the instruments based on criteria of price, service, whatever you would like to have in terms of, or availability, for example. So we can work with that as well. And again, same thing here. You can see that the difference here is not as large as it is on the other one, but you move it, and then you can also see that there is a larger spread here. So maybe I would like to move this one over here instead, but depending on who is doing the analysis and the justification regarding this. What we also can look at is, of course, the different probes, how to do this. So we might have the same instrument, but we have different probes for that setup. So here we have a multi-use probe, and we have a single-use setup, for example. Can we make sure that we can get them aligned in the same way, making sure that we do this going further? Because when we are then transferring the scale or the setup that we have, in order to do this in the best possible way. So this is what it looks like when we started, and then, of course, moving one or the other over to left or right. That's also what we are trying to do. Good. And of course, so that was probes, that was NIR, and of course we can do the same thing regarding the different application types. For example, here we have two different instruments, two different generations of instruments. Can we use that and work with that as well? Yes, of course we can do that. Here you can see that there is a small offset between the different generations, but in this case we can merge them and make sure that we use the data in the best possible way, transferring then the child up to the parent and making sure that we have the validation set up as well. Yep. So again, that was the short version of an addition on how you can work with these guided workflows, but also to give you a little bit an idea of what actually is possible when we start doing this, to try to make your life easier on a daily basis. Yeah.
Thank you, Johan. During your talk, I noticed that I didn't correct your slide deck, but it's okay for this time.
I think I had both PAT meeting, but
No,
I
you
also
had
have
user
user
meeting.
meetings on some of them. So
Okay.
I took both ends. So
You
yeah.
took the best of both
Correct.
worlds.
Yep.
Thank you. Questions to Johan? Always the guys in the last rows.
So if you transfer calibration from one system to another, I've tried this also quite a lot. Usually what I'm missing is how much prediction performance do you lose when you do that? Because usually you trade performance for flexibility or something if you do such a thing. Did you compare like a new calibration compared to a transferred calibration?
Yeah. There is a small shift that you can see, but normally we don't see any changes in the quality. Again, going back to the data and the quality of the first model, and again, if you have crappy data from the beginning, two crappy models will not make a perfect sample in the end. So, but I would say that we see very little overall difference between this, yes, and loss of accuracy.
Okay. Thank you.
Yeah, it's a little related question. What would you recommend if you have the choice to include a different instrument from the start in your calibration compared to transferring the calibration with this method? What do you have a recommendation? What is the preferred approach?
I would probably prefer to have different instrumentations already from the beginning to do that. But again, that is not the situation that we face. So this is an alternative to doing that. And again, as we are expanding, you're building new factories and things like that, where you can't always buy the last model that they had. You have to buy a new model or something like that. And then to make this easier, this is a way of making that easier. Is it the best or perfect? No, but it is a workflow that is accepted and that it works. Yeah.
Thank you, Johan. Very interesting topic. Practical question, does so you called this projection, I think, from one device to the other. Is this a pre-processing step? So are you technically taking, when you say you have a mother and a child, or parent-child relationship, the child's going to be transferred obviously somehow into the representation of the parent. So is that a pre-processing step? And what about if I later want to do maintenance on the model? Can I do the maintenance on the model and this transformation is automatically reapplied as it's maybe pre-processing, or would I need to redo that with all the instruments that I would like to include? So to what extent is this a once-off creation of the relationship between parent and child, or something to be redone in the future?
You always make the worst questions. So, and again, that's probably why you sit in the back as well. So, all the troublemakers sit in the back. let's try to break down your question then into segments in this setup. So if you make changes to one instrument, you do a service, you change a lamp or whatever is done, yes, you need to redo this because then it is a different instrument from what we had from the beginning.
I was referring to maintenance the model. So you have new data and you want to update the model that way.
Yeah. So if I have new data, I normally don't have to make the changes because what we did from the beginning, we were looking at the difference between the instrument. Yeah. And the model is then something that we can use on both of them because we know the difference between the two instruments. I would probably verify it afterwards, but again, you have a really good starting point. Yeah. So the calibration is one sample then.
Sorry that I walked into this corner, Johan.
I may be completely misunderstanding, but if I've understood what your response to Herbert's question was, is that if you change the data, if you change the data on one side, you don't need to change the calibration. Does that mean you have a standard calibration between two instruments? Therefore, you could potentially take some kind of calibration standard reading and then apply it across different products? Or have I just gone too far?
It's a good question, actually. I haven't tested that, but theoretically, well, probably you would be able to do that as well. Yeah, yeah. I have something to do with my new team now and test it, so, yeah.
So I left this corner of pain for you.
Thank you, thank you.
Owen?
Really interesting talk. At a previous job, we looked at using this and found that data augmentation of the calibration synthetically to include all possible future instrument variants. We unfortunately, sorry, Sebastian, had Sentronic instruments before they standardized the x-axis, and it was challenging, and we never knew what the future would hold. So we artificially shifted things, took a similar approach with the Raman. Have you compared that to the PDS approach and maybe kind of pros and cons on?
Whenever we do something and implement it into the software, we have, of course, done a lot of work prior to this, yes. So this is not the first off that we figured that this works or something like that. And it has also been in discussion with instrument vendors, making sure that we have accurate data to be able to test this, not only on one set of instruments or anything like that. So, yes. And that's the nice part about Sartorius now, when we have all the equipment, we have a bioreactor, we can run this, and I can play with even more data. So, yeah.
Okay. I guess we are going to release you now.
Thank you.
Thank you for this very interesting last talk. I'm a bit hesitant with clapping my hands while having this microphone here, so I'm not sure how noisy it will be. With Johan's talk, our first full day comes to an end. For the closing, I prepared a very, 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 very short slide deck. It's actually just one slide. It's really just one. The cover slide is always in. It just shows you the location of the Christmas market around, just in case, in the very unlikely case you didn't find them already. They are all around here. So we have the Streets market, which is always a bit in a competition and discussion with the Nuremberg Christkindlmarkt, who is the oldest. Spoiler alarm, the oldest is 50 kilometers to the east in Bautzen. We have a medieval one, which is just leaving the hotel to the right, 70, 80 meters down. It's very funny. And we have one on the Neumarkt, which is around the Frauenkirche, Church of the Lady, which is a bit more wide now and most often not that occupied. With this, we are going to close our first day. We cordially invite all of you to have dinner with us. The dinner starts at 7. 19 for the Europeans or for the Germans, down in the restaurant here in the hotel. Thank you very much, and see you for dinner tonight or tomorrow morning, the latest at 9. Thank you.